everyone, I want to welcome you to my YouTube channel. This is Steve coming back with another video. So before we go into this, I just want to mention that the machine language project is still underway, and that's the point of this video, is to kind of try to start discovering things that we need to do to help the project grow more. And also, I'm going to continue working on the machine language tutorial. That's going to be a little bit longer. Maybe I'll go over that a little briefly here today. But that's going to just involve a lot of, more research and books, and I've been researching a lot of websites and just doing a lot of work. So we'll continue back here very again soon. So let's get started with this. So before we go into any of this, I just wanted to show you, I am working on it. This is the machine language project. You may have saw last time I only had a section down here. So I'm adding in all of the tables for the different mnemonics that you can use, and the operands and everything, of course. And I've already added all those to the ones I've used so far, so we'll go over that later. And I've got a chart here for, I think this is the axis chart, yeah, axis chart, and I've just got some other things I'll show you later as we go through it here. So we'll put that out of the way for now to get started. So what I really want to focus on is this website. I've come across this many times before, and I've read a lot of different content on it. You may have as well. Codebase64, probably one of the best I've found for, finding stuff, getting code examples, and just learning stuff. There was one place in which I'm going to go over here now, that I always wanted to basically extract it and make it work with CBM Prg Studio. But I really didn't want to take the time to it. But now I realize where the project is and I need to kind of move stuff forward. I figured I'd better get started with that. So I have already done that. I'm going to show you. So to kind of give you a navigation, over here on the left-hand side is their menu. You can see you can navigate everything from the CPU, SID, VIC, interrupts, and so on, down to different programming languages, kernels. And of course, game coding is where we're going to go, and they've got stuff down here for, I think these are the links and stuff like that, and tools they use. So it's a really good place to get started. So let me click on game coding. So this is a great place for game programming. I haven't really had a chance to explore everything here yet, but I've explored a few things already. So if you kind of just want to look at it, it's got stuff here from Richard Bayless, who's done some really cool stuff. And it's just got other different things on here. I was just trying to check out these links here. Looks like they're still on the same site there. Okay, and there's some tools down here. And stuff for high score, sprites. But you can go ahead and check it out in your own time. I wanted to show you what I'm learning and trying to push forward in the project, which is scrolling. So I came across this by Malcolm Bamber, how to scroll around 2x2 tile-based map. So if you click on this first one, it kind of just shows you, let's see here, so how I scroll it's a 2x2 tile map. I wanted to do a 4x4, so I may be able to convert it over, but there is an example on this site also for a 4x4. He's just showing you what the interrupt request is doing. He's got the scroll up here. I'm not sure, and scroll left, I'm not sure why this is all here yet, but this is a guide or something. I don't really know. He doesn't explain this. But what I did, just going back here, you have to hit the back buttons to kind of get back there. What I did discover was this down here. This is his actual code, which we'll go into. So 4 ways to scroll part 1, and of course there's a part 2. And I had to take a lot of this code, and I transferred it, just copied it, just highlighted it and copied it over to CBM Prg Studio. I had to format the mnemonics, these are the instructions, toward the center because they won't work, and you also have to, when you do that, you have to format the labels and push them back over to the left again. Had to go through and change a lot of stuff in here just to make it work with the project in general. There was other things in here I was trying to get to them here. I think it's toward the bottom. Scroll down here toward the bottom. Right here, so the argument section here, I did change these parameter section arguments, what you want to call them. CBM Prg Studio does not like more than 2, I believe it is, and this has extra ones in here. I don't think it likes this extra. It's the operand, that's what it is, so it doesn't like the plus and the times in it. So you had to, fortunately I was able to just put these together and make it work. And then on the next page here, we'll skip over to that one. I'll go back. This one here is the next part, so you have to copy in this code too. This one wasn't too difficult, except I had to go down to the bottom, kind of doing the same thing again, formatting the code and, you know, flushing the labels to the left, but down toward the bottom here. All these bytes with the dots in front of them, you have to remove those because CBM Prg Studio does not use bytes like that. And there's a lot of bytes in here that had to be changed. So this took me probably a good hour or so to do this. And they go through, and then I had to work out some of the errors in the logic and try to make it work. So that's the example right there. So now I'm going to show you our CBM Prg Studio. So here's the code in CBM Prg Studio, and actually this is the one embedded in the project. Let me get the other one. It's not the one I wanted to show you. Sorry about that. I think it went on the other side. It's on the other side. Let me drag it over. So right here, 4 ways to scroll, I called it, obviously. And there's still some page boundaries in here that probably need to be fixed, but they're still allowing the project to run, so I'm not going to bother with those right now. And these are just, you know, alerts anyway, so kind of like warnings. But all the code is in here, and I'll go ahead and zoom in on it here. Although you saw it earlier, it's the same code. I haven't really gone through and changed anything. So let me just show you what it looks like, and we'll kind of test it out here. I already have it running here anyway, so I'm just going to pull it up here. This is what it looks like. It's a map, a 4-way scroller, as it says. It looked much better than I thought it was going to be. There is some errors with the timing on the scrolling, so you'll see me move it here. See, I'm kind of moving to the left there. It's a pretty big map. You can add it to it, you know. There's the bottom. And you can go up and down, of course. I'll put it on GitHub, those who want to look at it. Just scrolling through the whole map to show it to you. You have no idea how long I've been wanting to find a map like this. I knew I could never really build one. It would take too much time to figure out how to build one. But I found one on here, and he says whoever wants to use it, and I'll give him credit, of course, but it's free to use for your projects. So there's the map. We're going to later go ahead and we're going to change it to work with our programming stuff. So now I haven't really had a time to explore a lot of the code here, but we'll kind of go over some of it here since these are programming videos. But like I said, bear with me on this because I'm no expert on this stuff. I just started playing with this yesterday, and just copied it. So I'm just going to put this to full screen here. Maybe they're better if I leave them in full screen. Noticed. So you can see his name on there. He never put the date or anything, so we don't know when he wrote it. His website is inactive. I tried to pull up his website, and it does not pull up or anything. The page, but anyways, let's go back to the code. So you got the regular variables in here. Now he kind of swaps back and forth between hexadecimal and decimal. So at the top you've got the setup variables. These are the let's see, I'm not sure what this one does. Scroll stop, I think it has something to do with how far you're moving over or something. Maybe it stops it somewhere. A flag. This is the X scroll position. It centers the map. So you could probably move the map around by changing this. I believe that's it. Scroll X position near the middle, up, down. No, this is the size of the map. So you saw in those byte statements, we can go through and we could append to it and change it just by making sure that it has a width of 59 and a height of 36. And he's got a filter mode in volume, but I didn't see any sound in it, but that's alright. We're not worried about sound. This tells how far left and right we are in the map. So this is it right here. This changes how far left and right we are. So this might be the one you'd have to change. Not sure the difference between that one and that one is. It's probably just the scrolling. This one, unknown. He didn't put any comments on it, so I don't know. Although it's well commented. which side to draw the next tile strip, top or bottom. Which side to draw tile strip, left or right. Probably tells how it's being drawn or something. I don't know. But here's the pointer to the bitmap. The least significant byte and the most significant byte, you can see there. This one's set hidden screen bitmap, I think because he copies it to the back buffer or something. Which screen we are showing, 1024 or 3072. Yep, that's probably the back buffer right there. Set up memory for game. Okay. We could probably go to that one, but we're just going to go through it sequentially for now. This is the main loop. You got the interrupt request starting here. And just to kind of initializing everything here. Kind of stuff we kind of just went over. This has to be in the main map because when you're moving it, you have to know where the pointers are at all times as you're moving the map. Which is why this code is necessary. And this draws the map on the screen right here. So there's a JSR here I'm going to skip that draws the map for the first time. It keeps it on the screen. Not sure what this stuff is. Check interrupt requests. This is something to do with the draw bottom row on the screen. Oh, there's a bottom row right there. JSR draw the bottom row. And here's the swept screen. You have to sweep the screen, as I've learned in scrolling, to make it look better. Because if you try to just do like I did before and just try to copy the whole map on the screen and try to scroll it line by line, it's very slow and it looks very jagged. So by creating that second screen to swap to, it speeds it up. Although there is still something wrong with it. It's still a little jittery for some reason. But, I mean, it's better than anything I could have ever done. So here's the joystick initialization, and it's pretty self-explanatory. Up, and this is basically setting the scroll position. Let's see, set flag to scroll up. Yeah, so it has a scroll up flag, so it knows how it's scrolling. The Y scroll value, set screen starting position. Check for down. It's a down movement. I guess on the down movement, they're doing a little bit more here. I noticed this one. Oh no, this is checking the Y. Okay, so that's right, it's checking the Y. And this is checking the height. How far down it's going down the screen. Make sure we can still move down. Okay, so this basically determines if we haven't gone outside the map. Check for left movement. How far we can move left. And then we've got the right movement. Make sure we can still move right. So you got the max width there. As we saw earlier, it was set. And this is setting 38 by 40 column text display. And then here's where we're finally setting in the scrolling part. So this is what is this? This is the horizontal scrolling. And then we're setting bit 7 because we want to get 7 bits. Here, I notice we're turning on bits. Let's see, 0, 1, 2, 0, 1, 2. They're turning on bits 3 to 7. Or they're turning off bits 3 to 7 in the scroll part of the screen. Oh, so they're setting bit 7 and they're turning off all these other ones. So apparently I think they're just turning on this one right there. Okay. So next, map value. Work out Y values of map address. Like I said, bear with me on this because I've just started looking at the code, so I really don't have a full grasp on it yet. Just some of the common things. Y values of the map address, so it's up and down. Low byte return from multi-store byte 1. So I'll just skip over that for now, but he's got some good comments on here. Fill top row of the screen, screen address here, he kind of tells what they're for. The screen address, the color address, so this would be the color. for what 3 and 4 is the color, and then you've got the pointer for the map color, the address. X position is 10, and the axis value is in 12. So the color value for the map is 13. Okay, so fill is the top. Result from map Y times map width. Set across position on screen, how far across the map. Redraw on the top of the tile or bottom. Redraw on the bottom part of the tile. So I think it's just telling where it's determining that it's drawing, as it's drawing the map across there. Set X position, write out the character value, draw first, draw tile, draw second. Check how many tiles we have drawn. 39 tiles. That basically just draws it from 0 all the way across to 39. So if you look at the map again, it goes from 0 to 39 across. And if we've done a full row across at 40, then we can quit. Basically, it just draws out of this loop. So fill top was one of the JSRs you saw earlier. Jump to subroutine. And then we got the fill bottom. I think it just does the same thing on the bottom part, so I'm trying to figure out how he's doing this. Fill top and bottom. Get map result from map Y times map width. Set across position on the screen, how far across the map. This is kind of repeat except for the bottom part, right? Yeah. Fill the left side. So now we're going to be going down on the left hand side, of course. So we're going down here on the left hand side. Gets the map address so we know where to draw it. Counts the lines down. Count line drawn down. Set across position on screen. Set map X to left side of the map. Set across on map. Color it. Are we drawing the top or the tile or bottom? Set the character value to second line of tile. Okay. And this is likely necessary, if I'm not mistaken here, because when you're moving it, you want to know what is in that position as you're moving up and down, because it's going to be changing. So I think it's looking above it each time. I think that's what they mean by set the position from the top of the tile or the bottom. Just a guess there, but it seems logical. And this is, let's see, map color, map address, map color. And he's got some flags here. Hidden screen address. Hidden screen color address. I guess hidden means like offside, like off the screen or something. Let's see, fill right side. So it's going to kind of do the opposite. So obviously we're going to be doing it on the right this time. Count line drawn down, set across position on the screen. We always start at the first part of a tile. Set map X to the right side of the map. Draw tile 4. Draw left side, right side. So go and do this still as best as I can, copying the screen. I think this might be the back buffer. Let's see, copy screen left and up. So I notice he's copying the screen to the left and up on the left hand side here. Screen color, all the same thing. How many across to maximum? 39, of course. How many down to maximum? Which way are we scrolling it? Are we scrolling left? So he's checking positions here. to see which way it's scrolling. Is it going left? No. Then it's going to go to up. Otherwise, it's scrolling left. Check the next one for up. We're scrolling up. And he's doing a couple of different things with this one. Let's see, continue for, have we done 40 characters across? And this is for the up position, right? So as we're going up the screen, as we're scrolling up the screen, he wants to know if we've actually drawn all 40 across the screen there. And yes, increment the row counter. Add 40 to the next line. And then copy screen right 1, down 1. I have no idea what he means by right 1, down 1, but I guess right, because it's right and it goes down the screen. That makes sense. And it's kind of the same thing, except this is on the opposing side, of course. How many across the maximum? You can see it's consistent with a lot of the same comments, make it easier to follow. But like I said, I really don't have a full grasp on it. So there's where the screen is actually drawn for the first time. I just had no idea it would be this involved to draw something, I mean to make a four-way scroller. You have no idea how complicated it can be to really look at one. Draw start. This is kind of explaining write out character to the screen. So temp 0 kind of keeps track of what the data is on the screen. Move it right. Next XC value. Use value stored temp. We saw that being stored earlier. Values write out color to the screen. So this is in the pulling the color and then writing it out to the position. 39. Because there's 39 rows across, from 0 to 39, or 40 total from 1 to 40 if you look at it that way. So let's see here. I didn't want to make this video too long, but plus next line width. This is just all when it first draws on the screen, and I think it's keeping track of where it is at all times you're scrolling. It's filling this data in these variables as it's changing. So that's going to take a little bit more time to look at that. But here's a fill screen. He tells it, explains it, what color to use, what character to use, screen address, kind of the same thing again. Puts it in the screen, increases the byte counter. Are we on the last block of byte to write? I'm not sure what he's got the 3 here for. Yes, then only 231 bytes are need to be written. Is 0, then Y counter has wrapped around from 255, so we have done 256 bytes. So I guess he's drawn it in sections as he's going down the screen. If I had to do it again, I guess, you know, you can draw it down here and start here and then draw it there and so on. So I think he's drawn it in sections, which is interesting because it just basically it's filling the whole screen anyway. And then here's where it's all everything that gets put to the screen. So here's the XC value, or the what you see on the screen, the characters part of the map, and then here's the coloring. Oh, this is the color. I'm sorry, I meant the color. So it's the color, and the positions of the colors. And then here's that setup one. Now earlier I had turned off this setup, and I just saw a bunch of numbers on the screen, and I couldn't get it to work. But once I added the setup in. Initially, because it was in the second file and I couldn't locate it, it was working after that, of course. So what's inside of setup? We've got the color map address, probably some important things. Oh, coloring, that's why I didn't see any color on the screen. The map address would be important. the level, this draws the map, because this is where the byte statements are located, down in the level part. And the color map address, turn the cursor off, disable the keyboard, buffering, computer to where the new characters are. And then we are using, I think that's the interrupt, that's 53.267. So that's, no, that's not right, 53.267, D018. It's 53.272, so this is actually where the character data is located. Or actually where the horizontal scrolling is located. But right here, set the computer where the new character sets are, so it turns on the character set and use them. And then down in here, he's showing the starting location, chip range for the VIC. Okay, switch off basic. That's all part of when you're initializing the character set, border color, background color, and so forth. Here's where he sets the 24-25 column display and screen scroll position. And once again, we can look at this and see we got 0, 1, 2 is off, and then bits 3 to 7, whoops, is on. And then he's setting the Y scroll and turning, or these are off, and he's turning on whatever the Y scroll position is inside of here. Smooth scroll to the Y dot position. Alright. I guess that's just how you activate the smooth scroll. And down here, I'll talk about why he has it on here twice. Let's see. Oh, these are different registers, I see. So this is the vertical, and I think this is the horizontal. Set screen scroll position, scroll, yep, the X dot position, and this is the Y, and this is the X, I see. The interrupt, set up the interrupt, and he's got a raster, 251 raster position. So this I might need to play with later to get some of the jittering, because there's something, it might need to move the position or something from the raster line or something. Here's where he sweeps the hidden screen, because you always copy that second screen to speed it up. Which screen is being shown. And then he's just capturing some of these high and low bytes here, but I don't know what all this is yet. Hidden screen bitmap. So buffering, notice he's used a couple different buffers in here. Set address of screen, you can see current screen bitmap, address of screen. Alright, so set cursor, horizontal, column number in the Y register, and the vertical. I'm trying to figure out why he's using an X and a Y cursor position. He didn't have anything like written out on the screen anywhere that I saw. Print a 16-bit number to the screen. Maybe this is if you want to use it. It might not be used in the actual program yet. That must be what it is. And then here he's got something being printed here. Whatever screen buffer is. Get number, this is probably the number, probably for a high score panel or something like that. Move to next letter. There's nothing in it. Okay. Here we got set the print number to move to the next line after printing. This buffer is used to print a 16-bit number. So yeah, see there's a 16-bit number, although in the original one there's no numbers on here anywhere that I saw. It's just all character data, that's all. So I guess we could skip over a lot of this. Do the screen scroll. Here's where the interrupt takes place for the joystick position, setting up initialization. Do upper scroll, down scroll. And then here's the up down scroll. Scroll the screen up or down using the Y scroll and map Y. Smooth scroll to X dot position, just like we saw again. He's got the bits 3 to 7 and turned off, and then he's turning on this bit right there, hence the 7. Alright, so scroll away 2 times. We scroll each way 2 times. That's interesting. Down, up scroll, so up, down scroll, up, down scroll. I don't know if it's going up or down. I guess up to down, maybe it's going down. And then here's copy colors to the current screen. Carry on to 4, set new flag value. Okay. Get a little bit over my head right now, but at least you can see the code. Set screen scroll position, save new scroll position, because there's going to be, it's going to scroll 7 pixels. I know that much. And I think that's what the Y scroll is doing. Start scroll down. Check next value. Do we need to scroll again? Checking if we need to scroll again. Continue, copy to map up 1 position. Just kind of finishing the up down scroll. Vic interrupt request. Start scroll up. I'm trying to figure out what these 3s and all this other stuff is for. But in time I'll hopefully figure this out, because we're going to try to embed this into the project, as I mentioned. Give value to map pointer. Set scroll position. So here we're setting the vertical again. And this time for the bits 3 to 6 are on, but 3 to 6 are off. Well, they're on here, and then we're going to turn them off, and then he's setting bit 3 here, 0, 1, 2, 3. So do that on my calculator real quick and see what it comes to. In case you guys didn't know how to do this, you just basically, well, we'd have to put in this binary value first, actually. But it's taking what's in the vertical position, and it's using the AND to turn off these bits right here. But then it's setting bit 3, so maybe I'm reading that wrong, but okay. Let's see what we got here. Finish it out here. So go ahead and throw it in the comments if you guys are doing much better than I am, because I know you probably are. This might probably be my first real time for left to right scroll. So going from the left to the right. Set the screen scroll position. This is for the 53272, which is the horizontal. And then we're kind of doing the same thing again here with the masking and setting the bit, so we know which one to scroll with for the hardware. And setting up the interrupt to point to this new interrupt request. So the interrupt left right to request. And he's got left right 1 and left right 2. I think kind of figure out why he's doing, unless it's the swapping of the screen or something. Hasn't occurred to me yet. Bit interrupt request, set the registers. So smooth scroll to X dot position 0 to 7. So 0 to 7, this is the X scroll like we saw the Y scroll earlier. And here he's got bits 3 to 7 turned on, but he's got to AND them. which and is going to basically just turn them off. And then this is going to set bit position number 5. So if we had to look at that in binary, I probably could have showed you on here, my calculator back up there. We'll just go here and then we'll just type it in decimal 5, and you can see the binary, although this calculator doesn't show all the other digits. These are all going to be zeros after it, but you can see where the ones are. So it's going to turn on this one, turn off this one, and turn on this one. So it's setting bit 0 and 2. So I may have been wrong about the other one, but that's how they're getting the smooth scroll to the X dot position. Set scroll right. No match. Oh, and actually that would be right. I'm just showing you. Actually, I had it right. So this is just actually just showing you the bits that be set, but by the time you mask them and set them, it's going to have a different value there. But I don't know what the value is here, so I can't use this calculator for that unless I know what the set value is already in that register. So scroll down, scroll away 2 times. This video is getting too long already, but we're almost done to it. So then down here, just kind of skip ahead. It kind of just shows scrolling each way 2 times and stops the scrolling. Set R key to stop until joystick is moved again. Like I said, the code will be on GitHub. I just thought I would just take my jab at it and see what I could come up with. And this one is setting bit 2. Okay. Scroll the X dot position 0 to 7. Oh, because this is the says 0 to 7. Anyways, well, set screen scroll position. Set new scroll position. Smooth scroll to X dot position. Must have something to do with the back buffering. I can't figure all that out yet. So if you guys figure that out, go ahead and throw it in the comments. So now he's got several loops in here. I've noticed that too. Because I had to go back and I had to replace and rename a lot of them. Because the original program I also didn't mention, but it left a lot of these the same name. I have no idea how they use the same label all over the place. And obviously CBM Prg Studio picked up a bunch of duplicates, so I had to go back and change a lot of that stuff here. So these are the colors, or probably the second scrap screen or something. There might be more than 2 or 3 different scrap screens for what I'm seeing here. I'm seeing all these different, almost like there's 7 or something. I remember typing these in a lot. As I had to go back and change them. IRQ swap screen. This is just keeping track of which screen's probably going to be swept, I'm guessing. Which screen is being showed? Yep. Current screen. Second, here's a set current screen. Let's see if it tells in here. Address, current bitmap. Second, or set hidden screen bitmap, scroll position, the X dot, wait for the scroll screen. And then we got another interrupt going on here. So I'm seeing like 3, it's almost like there's 7 different screens or something. So, haven't figured that out yet. IRQ swap screen 2, this might tell me there's screen 2. Let's see. So maybe there's only 2. Random number, I don't know what he's using with the random number maker, but he's got one in here. And of course there's the end of it. So I didn't want to make this too long, but this is where all the level data is being read in. Here, the colors right there, the spare colors, which he puts in 0s there. The map addresses, so you can keep track of where the map is, I guess. Where the beginning address of the map lines is stored, it says. The character ROM, so this should be the character set, I think. Character ROM in. Yeah, this is the character data set right there. So that's pretty much my digestion of it, which is obviously pretty bad, but at least you could see it as I went through most of the code. You could see it in real time there, and I've enlarged it so you can see it. And we'll just kind of look at it again there. So I kind of made it a little bit bigger so you can see it. So yeah, that's pretty much what this program was going to be about. This video about. So I guess we'll just call this one quits. It's getting too long here. So I went back and I embedded it. You can see right here, scroll map, into the actual project here. And this was the result. Although currently I need to work on it. At least I could tell why it was jittering. It seems to be shaking the screen here as it's moving. You don't really see the map drawn here because our map is taking precedence over this current one, which later I'll have to change that. So, but I mean, that's as far as I got so far. You can see it scrolling though, right there, it's scrolling inside of the screen there, and it's scrolling through the colors and everything else, which we'll fix later too. But yep. So that's going to be it definitely for this video. So please favorite, like, subscribe to this channel. We'll continue to move the machine language project forward, and eventually my goal is to get this map or something close to it inside of this program. I'd like to be able to convert it to a four-way scroller. I mean a four-way tile-based map to be able to use more defined colors. But for now we got the 2x2, so I guess we could just deal with that. So yeah, I hope you guys like this and continue to watch this channel, try to get more videos out. And I do have one thing that I'm going to mention here also, is I ordered a cable for my Commodore 64 to plug into, you can't see it here, but in the corner I got my TV over there. So I'm going to basically be taking games from my Commodore 64 here and uploading them in composite mode to the desktop and saving them. I've got a new, you can't see it, but this is the Gamecaster unit I bought at Best Buy, and you can see the back of it right there. Last week a couple of us actually went through and they helped me get it working. The problem is I don't have the right cable to hook up, and I ordered recently the Commodore composite cable that'll plug right into here, and it'll plug right into my Commodore 64 unit so we can transfer it to the desktop. It does currently work with, like, if you wanted to copy like DVD and stuff, or you know, Blu-ray and stuff like that. But yep, that's going to be it for this video. You guys have a great day.